This is week 1 graded assignment solution video. In this week we have covered the following key concepts: joint PMF of two discrete random variables, marginal PMF of discrete random variables, conditional distribution, joint PMF of more than one discrete random variables, marginal PMF in case of more than two discrete random variables, marginalization, conditioning with multiple discrete random variables, conditioning, and factor of joint PMF. So in the G also we will cover questions related to these topics. So let us start with question number 1. Question number 1 says that 3 fair coins are tossed. If the first head occur on the first toss, you score 1 point. If the first head occur on toss 2 or on toss 3, you score 2 or 3 points respectively. If no head appears, you lose 1 point, that is, we score minus 1 point. Let x denote the number of heads and y denote the number of points scored. What is the probability that fewer than 3 heads will occur and you will score 1 or less? As x denotes the number of heads we get in flipping the coin 3 times, so the range of x will be 0, 1, 2 and 3, and the range of y will be minus 1 when we get 0 heads, 1 when we get 1 head and that's on the first flip, 2 when we get 1 head and that's on the second flip, and 3 when we get 1 head and that's on third flip. So in the question we have to find the probability that fewer than 3 heads occur and we score 1 or less points. So now let us try to find all possible xy pair for which this condition is satisfied. So for x is equal to 0, what values y can take? Y can take only one value and it is minus 1. For x is equal to 1, what values y can take? Y can take 3 values, that is 1, 2, 3. So x is equal to 1 means that we get only one head, and that head can occur on first, second or third flip. So that's why y can take 3 values. And for x is equal to 2, what are the possible values y can take? Y can take 2 values, that is 1 and 2. So if we get 2 heads, the first head can occur on first flip or it can occur on second flip. That's why y is equal to 1 and 2. So now all possible pairs are x is equal to 0, y is equal to 1. This is one pair. Second pair is x is equal to 1, y is equal to 1. And third pair is x is equal to 2, y is equal to 1. So now the required probability will be equal to probability x is equal to 0, y is equal to minus 1 plus joint probability x is equal to 1, y is equal to 1 plus joint probability x is equal to 2, y is equal to 1. Probability x is equal to 1 and y is equal to minus 1 means that we get 3 tails, that is, this is equal to probability of getting 3 tails, and probability x is equal to 1 and y is equal to 1 means that we get 1 head and that's on the first flip, that is probability of getting head tail tail, and probability of x is equal to 2 and y is equal to 1. This means that we get 2 heads and the first head occur on the first flip. So this will have two cases. The first is when we have head head tail, and the other case is when we have head tail head. So probability x is equal to 2 and y is equal to 1, this will be equal to probability of getting head head tail plus probability of getting head tail head. So now As the coin is pair, all these probability will be 1 by 8. So this will be equal to 4 by 8, which is 0.5. And this is the required answer. Now coming on question number 2. Question number 2 says that contracts for 2 construction jobs are each assigned uniformly at random to one or more of 3 firms A, B, and C. Let X denote the number of contracts assigned to firm A and Y be the number of contracts assigned to firm B. Find the value of probability X is equal to 2 given Y is equal to 0. So as the two contracts are distinct, so let us say let the two contracts be M and N. So these are two distinct contracts, and we have to find the conditional probability that X is equal to 2 given Y is equal to 0. So on using the definition of conditional, this will be equal to joined by marginal. This will be equal to joint probability that X is equal to 2 and Y is equal to 0 divided by marginal Y is equal to 0. And for finding the marginal Y is equal to 0, what we'll do, we'll add the probabilities of all possible XY pair where Y is equal to 0 is fixed and X takes different values. So this will be equal to joint probability that X is equal to 2, Y is equal to 0. For marginal Y is equal to 0, this will be equal to joint probability that X is equal to 1, Y is equal to 0 plus joint probability that X is equal to 2, Y is equal to 0 plus joint probability that X is equal to 0 and Y is equal to 0. So now on further simplification, joint probability that X is equal to 2 and Y is equal to 0, this will be 1 by 3 into 1 by 3 as both the contracts are assigned to firm A, and for the denominator, the joint probability that X is equal to 1 and Y is equal to 0, this means that one contract is assigned to firm A. And as both the contracts are distinct, there are two possibilities in this. One is contract M is assigned to firm A, and the other possibility is contract N is assigned to firm A. So joint probability that X is equal to 0. So joint probability that X is equal to 1 and Y is equal to 0, this will be 2 times 1 by 3. So this 1 by 3 is for a contract being assigned to firm A, and the other 1 by 3 is for contract being assigned to firm C, and 2 because there are two distinct contracts here. And for joint probability of X is equal to 2 and Y is equal to 0, this will be 1 by 3 into 1 by 3 as both the contracts are assigned to firm A. And finally, the joint probability that X is equal to 0 and Y is equal to 0, this means that both the contracts are assigned to firm C. So this will be equal to 1 by 3 into 1 by 3. So on further simplification, this is 1 by 9 divided by 4 by 9. So our required answer is 1 by 4, which is 0.25. Now coming on question number 3. Question number 3 says that joint distribution of two discrete random variables. Now coming on question number 3. Question number 3 says that joint distribution of two random variables X and Y is given as. So in this table, the joint distribution of X and Y are given. And we have to find the conditional probability that Y is equal to 2 given X is equal to 1. And before that, first of all, we have to find the value of unknown K. So since we know that the sum of probabilities of all possible xy pair in case of discrete joint distribution is equal to 1, that is, since summation of x belonging to domain of x, y belonging to domain of y, fxy is equal to 1, this implies that from the table, if we will sum all the probabilities, that will be equal to 1. So now this implies that 1 plus 4 plus 1 by 4 plus 1 by 8 plus 1 by 4 plus k plus 0 plus 1 by 8, this is equal to 1. So in further simplification, k is equal to 1 minus 3 by 4, which is 1 by 4. So now the conditional probability that y is equal to 2 given x is equal to 1, this will be equal to, on using the definition of conditional, this is joined by marginal. So this is equal to joint probability that x is equal to 1, y is equal to 2 divided by marginal x is equal to 1. And for finding the marginal x is equal to 1, what we'll do, we'll sum the probabilities of all possible xy pair where x is equal to 1 is fixed and y takes different values. So this will be equal to joint probability x is equal to 1, y is equal to 1 plus joint probability x is equal to 1, y is equal to 2 plus joint probability x is equal to 1, y is equal to 3. So simply for finding the marginal, what we did, we added the probabilities of this column here. So from the table, now we simply have to substitute the values. So this is the joint probability that x is equal to 1, y is equal to 2. This is 1 by 4 divided by 1 by 8 for joint probability that x is equal to 1 and y is equal to 1, plus 1 by 4 for joint probability that x is equal to 1 and y is equal to 2, plus joint probability that x is equal to 1 and y is equal to 3. This will be 1 by 8. So on first multiplication, this is 1 by 4 divided by 1 by 2, and this is equal to 1 by 2, and this is our required answer. Now coming on question number 4. In question number 4, customers at a fast food restaurant buy both sandwiches and drinks. The following joint distribution summarizes the number of sandwiches denoted by X and drinks denoted by Y purchased by customers. So this is the joint PMF table of X and Y given to us, and in this question we have to find the probability that a customer will buy 2 sandwiches given that he has bought 3 drinks. So in this question we have to find the conditional probability that X is equal to 2 given Y is equal to 3. So on using the definition of conditional, this will be equal to joined by marginal, that is joint probability that X is equal to 2, Y is equal to 3 divided by marginal Y is equal to 3. So from the table, the marginal that Y is equal to 3 will be equal to sum of the probabilities of this last row, because for finding the marginal in this case, what we'll do, we will sum the probabilities of all possible xy pair where y is equal to 3 is fixed and x takes different values. And from the table, the joint probability that x is equal to 2 and y is equal to 3, this is equal to 0.05, and the marginal is equal to 0 plus 0.05. So this is equal to 1, and this is our required answer. Now let us move to the next question. Question number 5 says that Akshay draws a card randomly from a well-shuffled pack of 52 cards. If the drawn card is a face card, then he draws 2 balls randomly from bag A, which contains 5 red, 6 black, and 4 green balls. If the drawn card is not a face card, then he draws 3 balls randomly from bag B, which contains 7 red, 9 black, and 4 green balls. Let 2 random variables x and y be defined as, so x is defined as it takes value 0 if the drawn card is face card, and it is equal to 1 if the drawn card is not face card, and y be the number of red balls drawn. So we have to find the probability y is equal to 1. So in the given question we have to find the probability y is equal to 1, or you can say we have to find the marginal y is equal to 1. So for finding the marginal y is equal to 1, what we'll do, we'll sum the probabilities of all possible xy pair where y is equal to 1x, 1 is fixed and x takes different values, and in this case x can take only 2 values, that is 0 and 1. So this will be equal to joint probability x is equal to 0, y is equal to 1 plus joint probability x is equal to 1 and y is equal to 1. And this is because if we have to find the probability of getting one red ball, that red ball can come from two bags, that is bag A and bag B. So the joint probability x is equal to 0 and y is equal to 1. This denotes that we got a face card, and after that we selected one red ball from the bag A. So out of two balls we are drawing, we get one red ball. And the joint probability that x is equal to 1 and y is equal to 1, this denotes that we have selected a non-face card, and after that we selected three balls from bag B and we got one red ball out of the three balls. So now this joint can be written as product of conditional and marginal. So this is equal to conditional y is equal to 1 given x is equal to 0 into marginal x is equal to 0 plus conditional y is equal to 1 given x is equal to 1 into marginal x is equal to 1. So now the conditional probability that y is equal to 1 given x is equal to 0, this will follow hypergeometric distribution, because in the bag we have three types of balls, and we want to find the probability of getting one red ball when we are selecting two balls from bag A. So this will be equal to 5c1 for selecting one red ball into 10c1 for selecting one ball out of rest of the balls. So this is the number of ways in which we can select one red ball and one ball which is not red ball. So and divided by 15c2, and this 15c2 is all the ways in which we can select two balls from 15 balls in bag A, into the marginal x is equal to 0. X is equal to 0 is probability of getting a face card, which is 12 by 52. Plus the conditional probability that y is equal to 1 given x is equal to 1. So this is probability of getting one red ball when we are selecting three red balls from bag B. So this will be 7c1 for selecting one red ball out of 7 red ball available in bag B, into 13c2 for selecting two balls out of rest of the balls. So this is all possible way in which we can select one red ball, two balls which are not red, divided by 20c3, and this is all the ways in which we can select three balls from bag B which has 20 balls, into marginal x is equal to 1. This is probability of not getting a face card, and it is 40 by 52. Now on further simplification, this is 5 into 10 divided by 105 into 12 by 52 plus 7 into 78 divided by 1140 into 40 by 52. And on further simplification, we get our required answer, which is 0.47. Now coming on question number 6. In question number 6, we have to check which of the given options are correct. So let us start with option A. So for checking option A, that is for checking whether the joint of x, y, and z is equal to product of conditional x given y and z into joint y and z. So we have to check whether this is equal to this. So for checking this, let us start with RHS. and try to get LHS. So RHS is conditional of X given Y and Z into joint of Y and Z. So on further simplification, we can write conditional as joint by marginal. So this will be equal to joint of XYZ divided by joint of Y and Z into joint of Y and Z. So these two will get cancelled and we'll be left with joint of XYZ, which is our LHS. So this means option A is correct. And for checking option B, we'll do the same thing. Option B says that the joint of XYZ is equal to conditional of X given Y and Z into marginal of X. Clearly, if we'll start with RHS, on first simplification, we can write the RHS as joint of XYZ divided by joint of Y and Z into marginal of X. Clearly, this is not equal to LHS, so option B is not correct. And C is correct because for finding the marginal, let's say for finding the marginal X is equal to some small x, what we'll do, we'll sum the probabilities of all possible XY pair where X is equal to some small x is fixed and Y takes different values. So option C is correct. And option D is not correct because the joint is equal to product of marginal is only true when the random variables are independent. So option D is incorrect. Now let us start with question number 7. Question number 7 says that two random variables X and Y are jointly distributed with joint PMF. So this is the joint PMF of X and Y. And here X and Y are integer values from 0 to 2 and 0 to 3 respectively. And the joint probability that X is greater than equal to 1 and Y is less than equal to 2, this is equal to 4 by 7. And we have to find the joint probability that X is equal to 2 and Y is equal to 1. In this question, the range of X is from 0 to 2, that is integer values from 0 to 2, and the range of Y is from 0 to 3, so integer values from 0 to 3, that is 0, 1, 2 and 3. And the joint of X and Y given to us is A times Bx plus Y. So here clearly we can see there are two unknown parameters A and B. So for finding the joint probability that X is equal to 2 and Y is equal to 1, first of all we have to find the unknown values. So for that, what we'll use, first of all, we'll use the axiom that sum of probabilities of all possible XY pair is equal to 1. So since summation of X belonging to domain of X, Y belonging to domain of Y, fxy, this is equal to 1. So from here we'll get one equation in terms of A and B, and that, so this is equal to, so this implies that joint probability X is equal to 0, Y is equal to 0 plus joint probability X is equal to 0, Y is equal to 1 plus joint probability X is equal to 0, Y is equal to 2 plus joint probability x is equal to 0, y is equal to 3 plus joint probability x is equal to 1, y is equal to 0 plus joint probability x is equal to 1, y is equal to 2 joint probability x is equal to 1, y is equal to 1 plus joint probability x is equal to 1, y is equal to 2 plus joint probability x is equal to 1, y is equal to 3 plus joint probability x is equal to 2, y is equal to 0 plus joint probability x is equal to 2, y is equal to 1 plus joint probability x is equal to 2, y is equal to 2 plus joint probability x is equal to 2, y is equal to 3. So this is equal to 1. So now simply put the values of x and y in the given PMF and we will get probabilities in terms of A and B. So this implies that on putting the value of x and y, we will get A plus 2A plus 3A plus AB plus AB plus A plus AB plus 2A plus AB plus 3A plus 2AB plus 2AB plus A plus 2AB plus 2A plus 2AB plus 3A, and this is equal to 1. So on further simplification we will get 18A plus 12AB, this is equal to 1. So let us make this equation number 1. Similarly, we will get another equation from the given probability. So the probability that x is greater than equal to 1 and y is less than equal to 2, this is equal to 4 by 7. So from this we will get another equation. So the probability that x is greater than equal to 1 and y is less than equal to 2, this is equal to joint probability that x is equal to 1, y is equal to 0 plus joint probability that x is equal to 1, y is equal to 1 plus joint probability that x is equal to 1, y is equal to 2 plus joint probability that x is equal to 2, y is equal to 0 plus joint probability that x is equal to 2, y is equal to 1 plus joint probability that x is equal to 2, y is equal to 2. So this is equal to 4 by 7. So now just simply put the values of x and y for finding the joint probabilities in the given PMF and we'll get the probability in terms of A and B. So this implies that on putting the values we will get AB plus AB plus A plus AB plus 2A plus 2AB plus 2AB plus A plus 2AB plus 2A, and this is equal to 4 by 7. So on further simplification we will get 6A plus 9AB is equal to 4 by 7. So let us make this equation 2. On solving, one and 2, we will get A is equal to 1 by 42 and B is equal to 2. So the joint PMF of x and y is equal to 1 by 42 times 2x plus y. So the joint probability that x is equal to 2, y is equal to 1, this is 1 by 42 times 4 plus 1, which is 5 by 42, and this is our required answer. Now moving on, question number 8. So in question number 8, a fair coin is tossed 4 times. Let x be the total number of head and y be the number of heads before the first tail. So we have to find the conditional probability that y is equal to 0 given x is equal to 2. So here we have to find the conditional probability that y is equal to 0 given x is equal to 2. So on using the definition of conditional, that is conditional is equal to joint by marginal, this will be equal to joint probability that x is equal to 2 and y is equal to 0 divided by marginal x is equal to 2. So now this this joint probability that x is equal to 2 and y is equal to 0, this means that we get 2 heads out of 4 flips, and the number of heads before the first tail is equal to 0. Now let us think of all outcomes for which this is satisfied. So this joint will be equal to probability of getting tail head head tail plus probability of getting tail tail head head plus probability of getting tail head tail head. So in all these outcomes, the condition that we get 2 head and the number of head before the first tail is equal to 0, this condition is satisfied. And for the marginal x is equal to 2, so this will follow a binomial distribution. This will be equal to 4c2 into 1 by 2 raised to the power 4 for getting 2 heads out of 4 flip, and simply just put the value of probability of getting these outcomes. So as the coin is fair, probability of getting all the outcomes is equal to 1 by 16. So this will be equal to 3 by 16 divided by 6 by 16. So this is equal to 3 by 6, which is 0.5, and this is our required answer. Now coming on question number 9, and question number 9, from a group of 5 members of party A, 2 members of party B, and 1 member of party C, a committee of 2 people is to be selected uniformly at random. Let x denote the number of party A members and y denote the number of party B members on the committee, and we have to find the joint probability that x is equal to 1 and y is equal to 1. So the joint probability of x and y will follow hypersymmetric distribution, and here for the joint that x is equal to 1 and y is equal to 1, this will be equal to 3c1 for selecting 1 member of party A and 2c1 for selecting 1 member of party B. So this is the number of ways in which we can select 1 member of party A and 1 member of party B, and this will be divided by total number of ways in which we can select 2 people out of total number of people, which is 6. So 6c2. So this is equal to 3 into 2 by 15, which is 0.4, and this is our required answer. Now coming on question number 10. Question number 10 says that a fair coin is tossed 5 times and the number of head n is counted. The coin is then tossed n more times. Find the probability that head will appear for a total of 4 times in this process. So let x be the total number of times we get heads, and small n be number of times we get heads in capital N flips, that is in capital N tosses. So what we have to find in this question, we have to find the probability that x is equal to 4. So this is equal to joint probability that capital N is equal to 2 and small n is equal to 2 plus joint probability that capital N is equal to 3, small n is equal to 1 plus joint probability that capital N is equal to 4 and small n is equal to 0. And this joint can be written as product of conditional and marginal. So this will be equal to marginal capital N is equal to 2 into conditional small n is equal to 2 given capital N is equal to 2 plus marginal capital N is equal to 1 into conditional probability that small n is equal to 1 given capital N is equal to 3 plus marginal that capital N is equal to 4 into conditional probability that small n is equal to 0 given capital N is equal to 4. So now the probability that capital N is equal to 2, this will be 5c2 into 1 by 2 raised to the power 5, because coin is tossed 5 times and out of the 5 times we want to find the probability of getting 2 heads. So 5c2 into 1 by 2 raised to the power 5, and the conditional probability that small n is equal to 2 given capital N is equal to 2. Here we have to find the probability that we are flipping coin 2 times and we get heads 2 times. So this will be equal to 2c2 into 1 by 2 raised to the power 2. So this should be 3 here. So this should be marginal of capital N is equal to 3. So probability that capital N is equal to 3, this will be equal to 5c3 into 1 by 2 raised to the power 5, because coin is getting flipped 5 times and out of that we want to find the probability of getting 3 heads. And for the joint probability that small n is equal to 1 given capital N is equal to 3, so here we are flipping coin 3 times and out of that we want to find the probability of getting 1 head. So this will be 3c1 into 1 by 2 raised to the power 3. Similarly, the probability that capital N is equal to 4 will be 5c4 into 1 by 2 raised to the power 5 into the conditional probability that n is equal to 0 given capital N is equal to 4. So this is 4c0 into 1 by 2 raised to the power 4. So in further simplification, this is 10 by 2 raised to the power 7 plus 30 by 2 raised to the power 8 plus 5 by 2 raised to the power 9. So in further simplification, we can take out 1 by 2 raised to the power 7 common. So we'll be left with 10 plus 15 plus 1.25. On further simplification, we'll get our final answer, which is 0.2. Now coming on question number 11. Question number 11 says that suppose a fair 6-sided die is rolled 5 times independently. Let x denote the number of times 1 is obtained and y denote the number of times a 6 is obtained, and we have to find the probability that x is equal to 1 and y is equal to 1. In the question, we have to find the joint probability that x is equal to 1, y is equal to 1. This means we have to find the probability that we get number 1 one time and number 6 one time when we are rolling the die 5 times. So in 5 throws of die we want 1 to come one time, so that will be 5c1 into 1 by 6 for getting 1 times, and for getting number 6 one time, that is out of the remaining 4 flips we want number 6 to come one time, so this will be 4c1 into 1 by 6. And for not getting number 1 and number 6 in remaining flips, this will be 2 by 3 raised to the power 3. Now on further simplification, this is 5 by 6 into 4 by 6 into 8 by 27. So on further simplification we get 160 divided by 972, and on further simplification we get our required answer, which is 0.164. Now coming on the next question. So here let random variables x and y be uniformly distributed over the set of intervals small x and small y satisfying. So small y is from -1 to 1 and x plus y, that is sum of the random variables, is from -2 to 2. So in the first part of this question we have to find the marginal PMF of x, and in the second part we have to find the marginal PMF of y. So since it is given that y is from -1 to 1 and the sum of random variables, that is x plus y, is from -2 to 2, so this implies that x is less than equal to 2 minus 5 and x is greater than equal to -2 minus 5. So from here we can find the values x is taking. So for y equal to -1, x is taking values -1, 0, 1, 2 and 3. For y 0, x is taking values -2, -1, 0, 1 and 2. For y is equal to 1, x is taking values -3, -2, -1, 0 and 1. So from here the range of x is union of all this, that is -3, -2, -1, 0, 1, 2 and 3. So now from here we can find the joint PMF table of x and y, and from there we can find the marginal of x and y. So this is the required table of joint probability of x and y. So from here clearly the PMF of x is, so when x is equal to -3 or 3, the probability is 1 by 15. When x is equal to -2 or 2, the probability is 2 by 15, and it is 3 by 15 when x is -1, 0 and 1, and otherwise it is 0. So this is the solution of first part, and in the second part we have to find the marginal of y. So it is given that y is from -1 to 1 and it is uniformly distributed. So the range of y is -1, 0, 1, and as it is uniformly distributed, clearly the PMF of y is 1 by 3 when y is equal to -1, 0 or 1, and otherwise it is 0. So this is the solution of part 2 of the question.